Okay, a few more examples here. Log base 2 of negative 4. What exponent do I put on 2 to get negative 4? Now let's go to the calculator and talk about this. 2 to the exponent 2. Now to me that's the first answer that pops into my head. Gives me positive 4. It doesn't give me negative 4. So I go lower than that. 2 to the exponent 1. What does that give me? 2. Go lower. It's got to be lower if I'm going to get to negatives. 2 to the power 0. Well, I hope you know what's coming here when I put in 2 to the power 0. 1. Anything to the power 0 is 1. So we'll do some negatives. 2 to the exponent negative 1. And something maybe you should really think about happens here. When I put a negative in there, I don't get a negative number. What I get is a fraction, or if you want a decimal. So that's not moving towards a negative number too much. And so even if you put a large negative value in here, say negative 50, equals 8.88 times 10 to the negative 16. This negative is talking about the exponent on 10. This is in scientific notation. This is very small. It's like 0.000000, like 15 times 888. So we're not talking about a negative number. In fact, no matter what number you put up here for the exponent, it's always going to come out to be a positive. Very small. You can go as small as you want. This is that asymptotic thing. It's asymptotically approaching 0. So no number that you put in for an exponent on 2 is going to give you a negative number. It's a basic property of logs. You can't take logs of negatives. So there aren't any exponents that I can apply to 2 to get negative 4. No solutions to this one. Oh boy. Exponent 5, base 5 of cube root of 25. Now the 25 does give me some confidence about that this is doable, but we do need some stuff from grade 11 here. Let me remind you a couple of rules, and these are good things to write down and put on a big piece of paper somewhere, because you're going to need these moving forward. This is supposed to be an a to the power of m over n. You might remember this from grade 11. A to the power of m over n equals, so when you've got a rational exponent, that is, you've got a fraction up in the exponent, the denominator of the exponent becomes the root number. And the numerator, the m, becomes the exponent. Now, you can put the exponent out here. That's where I like to have it, because the root makes things smaller and then I make them bigger. But there are plenty of people out there who write it like this, and it means the exact same thing. It will give you the exact same answers when you still nth root, but that the a to the power of m is in here. So this is like ultra important to know how to convert these fractions. Now the one we were given was, the question is, why would I use one over the other? And when it's in a rational exponent like this, let's talk about what that one is good for. That one is good for, well, it's good for lots of things, but the big one for now, this is good for combining with other things. So if you're looking to combine a expression with another expression, that's what that one is for. If you're looking to evaluate, then the exponential version of that, this one here, is not quite as good. Now, if you're looking to evaluate, you want one of these ones over here, whichever one kind of makes more sense to you in the situation you're in, and I like the first one. So that's what those two are really for. Moving forward, this one is the one we use for derivatives when you go into calculus, but we're really not talking about that here today. So, back to the PowerPoint. There we go. So, third root of 25. The way we can express that as 25 to the power of 1/3. Okay? Now that's getting better, that 25 to the power of 1/3, but still this 25 is doesn't work too well with the power of 5. So what we want to do is express 5 as, or 25 as 5 squared. And then, hey, exponent to an exponent. And in that situation, we can multiply the two exponents, and now we've got log base 5 of 5 to 2/3. Now, this is an important little moment here. Let me just say it out loud, and hopefully the answer will come to you immediately. What exponent do you put on 5 to get the answer 5 to the 2/3? Really think that over for a second. I have to put an exponent on 5, and I need the answer to be 5 to the power of 2/3. Well, keep rewinding that part of the video until you come up with that answer, because that has to be something that becomes obvious as we move forward with logs. The exponent you put on 5 to get 5 to the 2/3 is 2/3. That's the exponent I put on 5 to get 5 to the 2/3.